everybody. We are still in our virtual format, and we're working through those things, but learning is still happening, right? So here we are for a new lesson. Before we get started though, let's talk about what you'll need for this lesson. You will need your Cubes graphic organizer if you have it. You will need your spiral notebook with your notes. And for the do now, it's probably a good idea to have your integer addition and subtraction flowchart out as well. Of course, you'll need a pencil. Remember that when you return to school, whether that's Monday or Thursday, I'll be checking to see that you have notes for the lessons that we've had virtually since the last time that I've seen you. It's just my way of making sure that you're actively working at home and we're not losing any ground. So now, just like if we were at school, we are going to have a couple of do now questions. In fact, you have 6 today. I want you to go ahead and solve these 6 questions, and we'll be back on in a minute, or I'll be back on in a minute with the answers. So here we are with the do now. You'd probably notice that half of them were subtraction problems and half of them were addition problems. So 7, 8, and 9 in the top, you should have LCO'd for each of those. And for number 7, the first number 7, it's negative 66. For number 8, it's 14. And for number 9, it's 76. For the second number 7, we don't have to use LCO because it's an addition problem. So I just go to the addition part of my flowchart. I find the absolute values. Because they're the same sign, I add them. So I get negative 20. Number 8 is 75. And number 9 is negative 55. If you have questions, make sure that you jot those down. Remember, we have office hours on Thursday and Friday from 9 until 10 and 12:30 to 1:30. So in your notebooks now, under that do now, let's go ahead and write down our objective for today. Students will be able to solve addition and subtraction of integer word problems using cubes. We'll talk about cubes in a second. Make sure you're writing this about down. That's one of the things that I'm going to be checking for when you return to school on Monday or Thursday. Now, word problems always make students groan, and I don't know that when I was in 7th grade I disagreed, because word problems are kind of funny. They always ask things that are really weird, like if I have 98 watermelons and I want to share them with my 4 friends, how many watermelons does each friend get? Like, who has 98 watermelons, right? Yikes. But we practice word problems not really because we need to figure out how to divvy out watermelons, but because word problems are where we start to understand that the real world and math collide all the time. So, yes, some of the word problems are a little wonky and ask questions about things that will probably never happen to us. But really, it's a way to start training our brain to get to look at all kinds of information and organize it so we can work through it to find our solution. And remember, when we talked the first week of school, that skill is what math is really all about. Being able to look at a really complex situation and get to the end of it with a solution that works for as many people or as many things as possible. Okay? Now, the next thing I want to talk about is that my A students have a graphic organizer that looks exactly like this because they were in school on Monday and Tuesday. My B students, you do not have that. So I want you to hold tight, and you will be getting this graphic organizer when we return next week. But here's the deal. B students, you still need to take notes today. So in a second, I'm going to tell you what your objective is for the day, although it's not a mystery. Students will be able to solve integer word problems using cubes. But for now, in your notes, go ahead and write just quickly, it doesn't have to look perfect, the CUBES in your notes. Okay? Again, this is just for you now. You're going to get this graphic organizer when we return. Now, my A students, you're just going to fill out the graphic organizer that I gave you along with me the way that you see here. All right? So let's get started. The C stands for circle. Key numbers. Okay. So the first thing that we're going to do is circle key numbers when we're organizing the word problem. The U stands for underline the question. After we circle the key numbers, we're going to find what the word problem is asking us to do. Now, normally we're looking for a question mark, but sometimes word problems just tell us what to do, and we're going to underline that also. The B stands for box the key or clue words. What words are we given that help us know what we're going to do? Maybe it's things like in all, right, which signals adding. Maybe it's things like square feet, which is telling us that we're finding the area. We're going to box those. The E stands for evaluate. If you were Miss Mizio's student last year and you did E, you probably used explain the variable, which is what I used to do as well. But this year I'm going to try evaluate because I think it makes more sense for the kinds of problems that we have. And evaluate is just saying, what steps will I take? It's like making a plan. Okay? And S is solve and check. Something that's really important here, and something that I want to make sure that we build as a skill before we leave 7th grade, is asking ourselves, is this a reasonable answer? Right? So does this answer make sense for what we're talking about? Let's think about, I don't know, the watermelon example that I talked about before. Let's say I said we had, I'll make it an even number. So I have 100 watermelons and I want to share them with my 4 friends. How many watermelons will each friend get? Well, I mean, we know the answer. It should be 25. But let's say I make some kind of weird calculation and instead I find 400. If I ask myself, is this a reasonable answer? Then I'm forcing my brain to think, well, if I start out with 100 watermelons and I'm sharing them with my friends, how would each friend get 4 watermelons? That doesn't make sense. And so when we ask ourselves, does this make sense? Is this reasonable? We're slowing down our brains enough to check one more time before we submit our answer or before we share our answer. All right. So you're going to pause the video. You're going to make sure that you have these things written down either on your graphic organizer or in your notes. Again, B students, you'll have a chance to fill out your own graphic organizer. And A students, on your graphic organizer, in your own time or whenever, you can make this look as fancy as you want. It's blank for a reason. And remember, I've shared this before. When we spend time doodling and coloring, but we're doing it in a way that's focused on something that we're learning, it actually puts it in a special part of our brain where it's easier to remember. So maybe that means you're going to want to outline all of your cubes and make them funny designs, right? Or whatever. Feel free. right, so we've just filled in our graphic organizer if we have it. But I do want to add something, and that's before we even start circling and underlining and boxing, we should read the problem once without marking anything. So without picking up your pencil, you should always, always, always read the problem and just let your mind start thinking about it before you start organizing it. And then we circle the numbers, underline the question, box the keywords, evaluate, and solve and check. Oh, we notice here, I did not change this. So let's change that here to evaluate. All right. Now, in Schoology, is this PowerPoint for you to open and write on? Do not try to copy these word problems word for word. Split your screen so that you have the PowerPoint open next to this video so that you're able to mark the word problem as we go. All right, again, unless you are just dying to copy these word problems, please open it in PowerPoint, save a copy so that you're able to write on it, and work along with me in the PowerPoint. Okay? All right. So here we go. Here's my example. A submarine is at 400 feet below sea level. If it ascends 150 feet and then descends 320 feet, how far is it above or below sea level? All right. So I just read it. I haven't marked anything. And now I'm going to remind myself to cubes, and I'm just going to write this over on the side. Okay, so first I'm going to circle any key numbers or important numbers. So we've got 400, 150, and 320. Check. Now I'm going to underline the question. What is it asking me to find? And it's asking me to find how far is it above or below sea level? All right. So now it's time to box some keywords. All right. What are some things here that help me know what I need to do? Okay. So I'm going to box below sea level, right? If I have the ocean, that's sea level. If it's below sea level, right, that means it's down here. So that means this is negative. So above my box, I'm going to write down what that means. So I'm just going to write down negative. If it ascends 150 feet, well, ascends means to go up. And if I'm going up, that means I'm going to add. And then descends 320 feet. Descends means to go down. So that means I'm going to subtract. How far is it above or below sea level? So I've boxed my important words, and now I need to evaluate what steps am I going to do. So that's when I really kind of set up my problem, right? The submarine is at 400 feet below sea level. If it's below sea level, that means negative 400. It ascends 150 feet, so that means I'm adding 150. And then descends 320 feet. And we said descends means I'm subtracting. How far is it above or below sea level? So I'm trying to figure out this answer, right? All right, so now I just have a problem with 3 add-ins. I'm going to LCO if I need to, or just add numbers with different signs. My first 2 add-ins are negative 400 and 150. So I'm going to find the absolute values. Right? This isn't an LCO situation because it's a plus sign. So I have 400 and 150. They're different signs, so I'm going to subtract them. 400 or negative 400 has the higher absolute value. So my answer here is negative 250. And then I'm going to bring down my minus 320. Well, now we're in an LCO situation, right? So I'm going to LCO. I'm going to leave negative 250. I'm going to change the minus to a plus sign. And the opposite of 320 is negative 320. So I find the absolute values. And I get 570. It is, both of these numbers are negative, so my answer is negative 570 feet. Okay. Let me start over again. If we say negative 570 feet, we don't have to add below sea level. We could say 570 feet below sea level also. But we don't really say negative 570 feet below sea level because that doesn't really make any sense. It's kind of well, it is. It's a double negative, and we know that's kind of against the rules in English, and it doesn't make sense here in math. Okay? All right, let's look at a new problem. Here we go again with the ocean. A diver went 24 feet below the surface of the ocean and then 47 feet farther down. What is the diver's new position relative to the surface? Okay, so we have a word problem. I read it first without writing anything down, and now I'm going to remind myself about cubes. Okay, I'm going to circle important numbers, 24 and 47. I'm going to underline the question. What is the diver's new position relative to the surface? I'm going to box the key words. What are the words here that help me know what to do? Well, here we've got below the surface of the ocean, which means I'm talking about negative. And then 47 feet farther down. If we're going farther down, that means subtraction. And there you have it. So we boxed our keywords. So if I have a negative number and I'm subtracting, I need to evaluate and set up my steps, right? So I'm going to start at 24 feet below the surface of the waters. That's negative 24. And then I go 47 feet farther down. So I subtract 47. Well, I need to LCO. I'm going to leave 24 alone. I'm going to change the minus sign to a plus sign, and the opposite of 47 is negative 47. Find the absolute values. They're the same sign, so I'm going to add them. I'm going to get 71. Both of them are negative, so my answer is negative 71. So I can say negative 71 feet, or I can say 71 feet below sea level. Okay. All right, so now let's take a look at this guy. The video is going to pause, and it's going to give you a second to work on this by yourself. Okay, I'll be back on in a second to talk about the answer, and you can check your answer against this. All right, so in this example, I gave you one to work on that probably might be one of the tougher ones for today. And it says a submarine was at 1,200 feet below sea level and then moved to 1,683 feet below sea level. How many feet did the submarine descend? This question is a little tricky to figure out what it's actually asking you to do. But if we do cubes and then add one more strategy in here, it can help us figure out what we do. So I circle the numbers, right? I have 1,200 and 1,683. I underline my question. I want to know how many feet the submarine descended. That's an important thing to think about. How many feet did it descend? Not its sea level, like not its depth, but just how many feet did it move? I'm going to box the keywords. I have below sea level and then below sea level again. So we've got two negatives. And so that leaves us with knowing what steps to take. The only thing that's helpful here is that it moved, right? Okay. So sometimes another strategy that we can add to cubes that kind of goes in between the B and the E, something to help us know what to do, is to draw a picture. So let's say this is our ocean, and you're not allowed to make fun of my drawing, okay? So if the submarine starts off, right, the submarine is right here. Here's my submarine. It starts off at negative 1,200 feet. And then it moved, right? It goes farther down, and its new depth is 1,683 feet. The question's asking us how many feet did the submarine descend? It's asking us for how much space is between where it was and where it ended up. It's asking us for this distance. Well, if we're figuring out that distance, what we're really doing is subtracting them, right? We're subtracting the end from where it started, which means I set it up as negative 1,200 minus negative 1,683. And then I LCO, and I get positive 483 feet. And this is really, really important because it's asking me, it's not asking me its depth. It's asking me how many feet did the submarine descend? And this goes all the way back to what we talked about with absolute value. Distance is never negative. So because even though it was traveling under sea level, the distance is still a positive number. It's 483 feet. Take a second, make notes where you need to make notes, and we're going to do another example together. All right, so here we have an example with a picture. So we don't have to draw it this time. Go ahead and read it on your notes, on your PowerPoint. Underline or circle, underline, box, evaluate, solve, and check. And when you get your answer, come back on. All right. So here we're finding the difference in elevation between Death Valley, California, which is 282 feet below sea level, and the summit of California's Mount Davidson, which is 928 feet above sea level. So if I'm cubesing, which isn't a word, but if we're using cubes to organize our information, we first start by circling our 282 and our 928. I underline the question. Here, the question's in kind of a different place, right? It's telling us what to do in the first sentence. Determine the difference in elevation. So that's what's underlined. Now, I box the keywords. Difference is what tells us to subtract. Below sea level tells us the value is negative, and above sea level tells us that value is positive. Then I figure out my steps. What steps do I take? Well, I boxed a word that tells me that I have to subtract. And if I'm finding the difference between Death Valley, California, and Mount Davidson, that means I'm subtracting Mount Davidson minus the Death Valley elevation. So I have 928 minus negative 282. So I LCO, and I get 1,210 feet. So sometimes these kinds of questions trick us because we see difference and our brains are kind of conditioned to think, well, if I'm finding the difference, my answer is going to be smaller than either of the numbers that I start with. But see, because the difference is talking about something that's above sea level and something that's below sea level, where actually it's going to be greater than either of them because we're combining those two. So if I was climbing up from the bottom of Death Valley, right, all the way up to the top of Mount Davidson, I'd be climbing 1,210 feet. Pretty cool stuff. All right, one last example for us to try together, because this is really important for us to be able to do. Go ahead and read it. Work on using cubes, solve it, and come back on here in a second to check out your answer. All right, here we go. This question is a lot like the last question, except now we're talking about two different towns. A particular town has an elevation of 8 feet below sea level. Another town on top of a mountain has an elevation of 2,421 feet above sea level. What is the difference in the elevations of the two towns? And like for us, there's a picture here that helps us understand that we're finding the distance, right, between this town and this town. So even though it's asking us to find the difference, we're actually finding the space between those two places. Okay? So I'm circling my key numbers, 8 and 2,421. I'm underlining my question, which here it does come at the end, right? What is the difference in the elevations of the two towns? I'm boxing my key words. Below sea level is negative. Above sea level is positive. Difference tells me to subtract. I evaluate, so that's where the LCO comes from and where I set up the subtraction problem. And I go ahead and solve it. And I check to make sure that my answer is reasonable. Does it make sense that the difference between these two places is larger than the actual elevation of either? And it does make sense because one of them is actually below sea level. All right. So I know this lesson is challenging. I know it took a little bit longer than most of the lessons that we've done so far, but it's one of the most important things that we're going to learn this year because we're always going to return to cubes. I just want to make sure that we understand it as best as we can right now. So you're going to have a couple of problems to do as an exit ticket. You'll submit your answer, and I'll be checking for your work on Monday or Thursday when we return to school. Again, if you have any questions, please stop by our office hours. They are on Thursday and Friday from 9 to 10 and from 12:30 to 1:30. The Zoom links are in Schoology, so stop on by, ask your questions, get your help if you need it, and I'll see you either online in Zoom on Monday or Thursday.